Okay, so I have some important points to make about nomenclature. So what I want to do is kind of make this video to preface the ionic compound information, the molecular compound information, and the acid information. So this is kind of why we care about what we're about to do for the rest of the chapter, rest of the course, anytime we're talking about chemical molecules, okay? So we need to talk about nomenclature, why it's important, and why we actually care about what we name our molecules, okay? So nomenclature is the name for the set of rules we use to name our chemical molecules. Nomenclature and naming are kind of interchangeable here. So we need a set of standard rules so we all know how to talk to each other and we know what we're saying, okay? So nomenclature has evolved over time to be more useful, more consistent. So there's some older naming schemes that just don't make as much sense. We had like different names for all the different kinds of acids. Like instead of calling it just acetic acid, the name that we would generally use, we might have called it glacial acid back in the day, or things like that. Or I know like muriatic acid is one of the acids we eat quite often. It's the acid that makes warheads sour. However, that's not actually the official name of the acid, of course. So nomenclature has evolved over time so that when we're talking about chemical molecules, we know what we're talking about, and so that we can gain certain kinds of information from the way we name our molecules as well. So that's why we might have different kinds of nomenclature. So we're going to talk about how to name certain kinds of molecules, and we're kind of going to use what I'm going to call the chemistry way of naming it. So this is going to be kind of generally what we would use in chemistry to name our molecules. And so in different situations, different kinds of molecules might have different ways to name themselves. Different areas of chemistry might call a molecule one thing, and others might want to call it something else. That can help to point out different like features of our chemical formula or molecule or whatever we're talking about here as well. So we might want to highlight one part of the name. So organic chemists talk about it one way, whereas inorganic chemists might be interested in another part of the molecule. So they want to put that part at the forefront and in the name first and foremost. So we're going to learn about a couple of different kinds of molecules in this chapter. We're going to learn how to name them, and then we'll continue to add to our toolbox throughout the semester, of course. So sometimes we might just say and use the old names. For example, ferrous oxide is one I have definitely heard before. In this class, we would call it iron 2 oxide. I would prefer to call it iron 2 oxide. But some of these older names, like ferrous, was indicating the charge on that iron atom there. So if we're thinking about FeO, we might call it ferrous oxide, or we might call it iron 2 oxide. We're always going to defer to the chemistry names, but this is just like one good example of an old name that we have. And medical actually has its own naming conventions, and it's driven a lot by patent and copyright laws, of course. We want to patent drugs so that other people can't reproduce them. So that's how a lot of their names come along as well, is because when we name them, we have to make sure that they're different enough in name so that people can distinguish them and they follow all of the intricacies of patent and copyright laws. Fun fact, actually, one of the things when you graduate with a science degree that you get a lot of are like offers for you to go to law school. Not like, offer for admission or anything like that, but, you get a lot of informational packets from law schools sent out because you actually have to have a science degree to become like a patent lawyer in that area first. So you have to get your science degree and then you get your law degree so that you can study like scientific patents, for example. So a lot of times they try to recruit out of the sciences because I didn't know you could do that. So one thing you can do with a science degree is become a patent lawyer. So if you're kind of interested in science or interested in other areas, or maybe you don't like the jobs scientists have, it's another way that we can work with we can still work with some of the things we're using, but it's just kind of in an adjacent area of patent law. So you still have to have a deep understanding of chemical molecules to work in, like medical patents, for example. However, you got to go to law school on top of that because let me tell you, I don't know how to be a lawyer. I just know how to be a scientist, and I went to get my master's in chemistry instead. So just Something different you can do with chemical molecules, but again, that's kind of how the medical naming is driven, is by those patents and how those lawyers understand those chemical molecules. And then when you read the label on like a consumer product, so if I take my hand lotion here, I can see that it says like purified water, glycerin, stearic acid. Not quite sure what that is. You'll find soon that it's not going to fit the naming rules we're going to talk about for acids. But you can start to pick out some of this stuff. Oh, look, there's propylene glycol. We used that in the mass percent lab. So there's going to be a few things you can pick out. Some things we'll start to be able to name on here. But oftentimes when you read a label, you're going to see some of the conventions we're going to learn in class. And then you'll also see some of those medical conventions. You'll also see some of those older names. A lot of times too, like if something sounds really chemically but it's not, we wouldn't want to call water dihydrogen monoxide and have that be the first thing, or the bubbles in your pop are carbonic acid. So you wouldn't want to say carbonic acid is your number one ingredient, because people read that and they say acid, oh, that's scary, even though it's not, it's just the bubbles. So sometimes they can choose to use all these different naming schemes when we look at just a product, so that it might help reassure the consumer that they know what they have if a common name for a chemical is used more often than others. So there are different kinds of nomenclature for different kinds of needs. We're going to learn the chemistry format. We're going to learn kind of that more straightforward format. But some of these other names and some other things that we talk about might go as well. Like, again, we use the word water instead of dihydrogen monoxide for H2O. So just a little bit of fun facts, some information about nomenclature there. So as we're talking about this, really, why do we care? Because we can get information from the names of our molecules. As we start to talk about the different kinds of molecules, we'll start to talk about the information that we can gain from those names, okay? However, it can be specific to the kind of molecule you have, so we'll talk about that a little bit later. So nomenclature allows us to communicate to each other. I can say a chemical formula or the name of a molecule to you, and you can give me the opposite piece back, because we know what we're talking about. And it also gives you information if it's named properly. So it might have certain information, because I can tell you that the iron atom in FeO has a charge of +2 based upon the name there. We'll talk about how to find that out when we talk about ionic compounds. But again, I found the charge of an ion just from the name. Okay, so there's information contained in the name, and it allows us to talk to each other so that we know what we're talking about. However, with naming, with anything, we have some things to be cautious about, just like with the chemical formulas. So nomenclature, a small tale of caution, okay? So the first thing I want to mention here is spelling. So spelling is important, but it's not everything, okay? You will always have your periodic table, so you can always look back at your periodic table. You can triple check the spelling on there, okay? The deal I'm going to make with you is thusly. I'm going to take half a point off for spelling errors on each problem, up to 2.5 points for each assignment, okay? So you're not going to get killed by the spelling if you happen to spell things wrong. If it takes you a long time to spell certain things, it's, you'll have time to move on, and it's not going to ruin your grade by any means. I care that you spell things correctly, and I want to emphasize that you need to be sure you are triple checking. However, it's not going to kill your grade if something like that happens, okay? However, I have one caveat. If your spelling mistake causes me to think something else other than what you intended it to mean, I reserve the right to count that wrong, okay? So if I can't read what you've written and I can't determine exactly what you mean, I can't really give you the credit there, okay? So while spelling is important, it's not everything, but you have to make sure you're actually saying what you intend to mean, okay? Like if you see the chemical symbol Se for selenium and you write down silicon, that's not a spelling error, and you can't convince me it's a spelling error. You read the chemical symbol wrong, okay? Just the same thing here. So if you use the wrong chemical or elemental name, it may be counted wrong as well, okay? So fluorine is actually spelled Fluorine. We don't usually think about UO in English. It's usually always OU. So this is a spelling mistake, but I'm going to know what you mean. It's in that half-point range, okay? But again, sulfur and selenium are two different things. You must specifically point that out, okay? So again, if your spelling mistake causes me to think that you have the entirely wrong thing, I reserve the right to take the points. However, if you do something weird like use an O's swapped in fluorine, I'm going to get it. I'm going to know what you mean, but I reserve that right to take half a point because you could have checked it on the periodic table, okay? And then last bit here is something that we'll be cautious about. I want to mention it here. We'll talk exactly about these naming schemes as we move forward, okay? But I want to point out that if you use the wrong ion name, you use the wrong formula, you use the wrong formula name, it still may also be counted wrong, okay? So fluorine is the elemental name for the neutral state of an F2 molecule. However, fluoride with a D is the ion name. We'll talk about how to name ions in a bit, but the ion name that means actually one atom with a 1- charge is fluoride, okay? So if you don't use that ion naming scheme when we start talking about ion naming schemes, I reserve the right to take that half point again, or to count it fully wrong if you mean something other than what you intend, okay? And then the last thing here is like the difference between sulfate and sulfite. These are two different compounds, right? Sulfate is SO4 2-, sulfite is SO3 2-, okay? You have to be sure that you say the one you mean. It's not a spelling mistake in my mind to go back and forth between these two. Triple check you have the one you mean, put your A, put your I. They're on opposite sides of the keyboard. No spelling mistakes there, okay? Make sure you're talking about the polyatomic ion you mean. So nomenclature is important because it allows us to communicate to each other. We get information from the names of our chemical molecules. However, you need to be cautious about how you're naming them, but spelling isn't going to kill your grade by any means, okay? So be cautious about what you're moving through and what you're doing. You have to be cautious that you say what you mean. However, I understand if you flip a letter or two along the way, okay? So that's our introduction to naming. Go ahead and now watch the videos for ionic compounds, molecular compounds, and acids so that you can learn how to name these individual kinds of compounds and some features and properties of those kinds of compounds as well.